Today on Xenodilodon, I'll be completely tearing down an Irradiant Revo 100 moving head light. Now these lights are a little over 10 years old, and back when they were made, a lot of companies were still using high intensity discharge lamps inside of their moving head lights. However, the Revo 100 is one of the earlier ones to adopt using LEDs instead. Now granted that this light is a little over 10 years old, the LED on the inside and the moving headlight itself has seen better days. However, it still contains a whole bunch of goodies that I think a lot of you would be interested to see. This isn't the one I'll be tearing apart. I already have one that I took all of the covers and stuff off of. Let's take a look at that one. There's what the inside looks like. It's a bit dirty, and I gave it a shower with the hose outside, but I think we can still plug it in and give it one last show. What do you think? Let's see if it smokes. What do you think this is? A party? One of the most important things about the entertainment lighting industry is the reliability of a certain light fixture to do its job and do it consistently. Keep in mind these lighting fixtures can be up on a lighting truss and therefore hard to access. Now the problem with this particular moving head is that it has a problem finding the correct home position for the tilt function of the moving head. So the tilt function is this function right here, and the pan function is this movement here. Now it could be a problem with this little Hall effect sensor here, but I'll show you what the problem is. So when a moving head is turned on, it'll find end stops for both the tilt and the pan function. So it'll move, it'll stop, it'll rotate, it'll stop, and then it'll use optical encoders to count the steps of motion on each one of those axes. Let me show you what happens when this is in a certain position and I turn it on. It'll continue to do that for the duration that the moving head is on. In order to have it operate properly, I have to physically take and tilt the head all the way around and restart it. And then it'll operate correctly. So this moving head fixture is simply just not reliable enough for everyday use. Let's tear it down. There are three main parts to a moving head light. There's the head, the yoke assembly, and the base on the bottom. I'm going to start with the front of the head assembly, taking off this lens, and then working my way down to the core of the fixture. Let's start here. So this is one of three lenses, and this is where the light comes out of. Nothing really too important about it. It's a convex lens and just provides the final focus and output aperture of the moving head itself. Oh, that's a plastic bracket. Okay. Expected the lens to pop out. And it looks like the front lens is actually riveted in that piece. On the inside we'll have a couple of parts. We have here the shutter mechanism, which opens and closes like that. And then we have a three-faceted prism. And what this does is it divides the output into three parts. And then we have two more steppers over here. One stepper is on this side, and it moves the three prism assembly up and down like this. And there's another stepper underneath it that has a gearing system that will spin that three-facet prism around in circles. So the prism assembly sits inside of a roller bearing. You can see all the little ball bearings on the inside of that. And now we can remove the shutter assembly. It's going to hold that on. The motor shaft. And you'll notice that the shutter assembly also has this plastic band on it, which links the two shutter arms together. So you can pull that one off. Nope, not yet. That was just for the band. Where are you, little set screw? There it is. Now if you're doing work with steppers, there's often a little set screw that holds things onto the stepper motor rotor. Let's see. There's that screws underneath that one too. Okay. Here's that little band that joins those together. Oh, there's no set screw on that. I see. Okay. Comes up from the front. Choose your weapon. No, there's a little bolt on the back of that. I see it now. God, flathead screws, man. And there's the kind of bearing assembly for that. Alright, now the next bit is to pull off this front assembly here so we can get access to the other steppers. I'm going to take off the gears. And we can see the bearing on the back of that and how that rolls along. So, let's see. Well, plug the steppers going to that part. Take a look at what we have on the other side. And that end stop looks to be like another point where it's screwed down. No, that's more than finger tight. Now before I remove this assembly, I want to show you the focus assembly here. So this stepper right here has a little arm on it, and this arm brings this piece up here back and forth. And that piece is on this lens on the inside here. And we can see that it moves that lens in back and forth like so. And that is the focus for the moving head. These are the last two screws to come out, I believe. And there we have this assembly, which has 4 steppers, one for the triprism, one for the triprism rotation, the other one for the shutter, and then this one here for the focus mechanism. So this area slides in here, and this assembly right here pivots back and forth. We can go ahead and remove that lens as well, which is the primary focusing lens, which adjusts how clear the image coming off the moving head is. Now we're going to work on the LED side of the head itself. On the back of the head itself is where the LED, the heat sink for the LED, and the fan is. We're going to see one roasted LED. I can guarantee you that. This thing is nowhere near putting out as much light as it's supposed to. It's supposed to be a 100 watt LED. It's maybe putting out 10 watts. You'll see why. There goes that. On the inside you can see the heat sink and the rest of the assembly. So 4 screws holding that in. I'm going to remove this fan on the bottom first to get a little bit more access. Go ahead and freeze that up. And then pull the LED out. Oh, that screw's lost. The amount of hardware that you get from a moving headlight is absolutely astounding. It'll feed your project for days. Before we undo that last screw, disconnect the LED power wires. There's a little relay board right here that's connected to the fans, and I also believe it's connected to a thermistor to keep an eye on the temperature of the LED itself. That way if there's a fault, the relay will cut the LED off and try to prevent damage. However, it didn't really do its job. Alright. Nope. There are more screws. The fact that this whole thing moves around does not make undoing screws any easier. I'll tell you that right now. Alright, there's the LED and lamp assembly. Yeah, that's what the LED looks like. That is one toasted LED. And they don't make these LEDs anymore, sadly. Can't find replacements, but oh, that's ugly. Woof. So there's a heatsink assembly for the LED. Little fan on the other side to try to keep it cool, which you know you could have done better on. Here we have the reflector and the focusing lens for that. Quickly open that up. Get a good look on the inside of that. Oh, those are on. Yes. Oh, so close. It looks like I'm fumbling around with tools. Well, believe me, I am. Keep in mind I have to hold this up in front of the camera while doing this. there's the lens. Pretty big lens. It's a pretty thick one too. Has some gnarly curvature to it. And then the reflector assembly. So the LED sits in there just like that. Oh, so ugly. I'm going to remove these two last pieces of metal here, along with the relay assembly on the back, so we can get into the other parts. There's the little relay. Being more of a laser tech, this particular part is my favorite part because it has the color wheel inside of it. In the middle of a moving head fixture, there are a couple of different wheels. There's the color wheel, usually a stationary Gobo wheel, and then sometimes a rotating Gobo wheel. This one just has a rotating Gobo wheel, and I'll show you exactly what that is when we get to the inside and how that's put together. I'm going to free up some of these cables first. Oh, that one hit me right in the face. It's fighting back. By the way, these wires are excellent wires. They have very thin copper on the inside, and that gives them a lot of flexibility to them. Which means they're good for things that move and flex quite a lot. It's an excellent wire. Let's undo this one here on the bottom, which is wiring going to a little sensor. Pull that off. And I think we can pull off this entire plate now. Take a look on the inside. Oh yeah, good. The other side is attached still. Okay. So here's the color wheel, and the color wheel has pieces of dichroic glass, and dichroic glass is just glass that has an oxide coating of different metals depleted on it, and it has a thin film effect where it splits up the light. You have a reflection, and you have the pass-through color. I'll show you a little bit more of that when I get to pulling that off. And you have a rotating Gobo wheel, which utilizes two steppers. There's one stepper that the Gobo wheel assembly is on, which will allow the entire thing to rotate. And you have another gear right here, which actually spins all of the Gobos around in circles like this. Let's pull off the Gobo wheel. confusing. So here's the gearing for that. It's basically the same as the three-faceted prism, where you have a center bearing and post, and the outer gear that spins, which is driven by this stepper motor right here. Take a look at the Gobo wheel itself. Each Gobo is on its own gear, and when the gear in the center spins, it moves all of these at the same point in time. And each one of them has a little cutout that will shape the light as it goes through. We even got some little diffracting glass here, and a little pane of glass that looks to be made of different pieces of dichroic material. Same thing, they all have ball bearings around the outside, which allows them to spin pretty smoothly. Put that in there. Work on it. I'm going to pull off the color wheel. I'll pull out this sensor first. So the way that these find the proper position, the Gobo wheel and the color wheel, is that there's a little magnet on the outside of the wheels, and there's a Hall effect sensor that picks up the location. So the board that I'm taking off right now has that little Hall effect sensor on it, and I'll show you that. So right there you can see that little Hall effect sensor, and a little magnet's probably on the other side of the wheel, but the Hall effect sensor picks up the magnet. Oh, here it is. It picks up the magnet. It says, okay, well, that's our home position, and then from there it'll count the steps. Well, not count, but based on the steps that the stepper motor takes, the fixture knows where the wheel is. Now, the reason why they use a wheel like this and not just an RGB assembly, it has the advantage of giving you two colors. So for example, if it's halfway between the blue and the pink dichroic filter in the color wheel, you get both the pink and blue in one output. Whereas if you're using an RGB LED, you can only use one of those colors or a mix of those colors and get a single color output. Yeah, I love dichroic glass. That's one of those commodities that I use quite often when working with lasers, because they're great for joining different colors of lasers together. Having such a wide variety of laser frequencies, wavelengths, having an assortment of dichroic glass is extremely helpful. And here's the color wheel. Here's why the color wheel is my favorite part inside of a moving head projector, and that's because of the dichroic glass, which is borosilicate glass that has several layers of metal oxides depleted on the surface, and it uses thin film interference to split the colors up two ways. The first way is the reflection, and the second way is the pass-through color. So for example, on this one, you'll see more of a yellowy orange, light blue, and pink, and if you look through it, that gives us the green, the red, and kind of a lighter blue, but that also allows me to mix different colors of laser together. So let me show you. If I wanted to mix red and green, I'd use this dichroic filter just like this. I can mix those together. If I wanted to mix red and blue, I'd use this dichroic filter right here. And so on. So this glass is very valuable for me to have around. Besides, it looks absolutely gorgeous. Oh, I wonder what that little LED here is for, if that's a little photo sensor or something. Maybe for feedback on the LED. Not quite sure. That's a new piece for me. I haven't seen that before. Yeah, PH1. Gotta be photo sensor. Oh yeah, big old black square on there. No question about that. Wonderful standoffs inside of these moving heads too. Let's see. I'll remove this centerpiece, and then we can start in with the Yoke. Rip those wires, pull them through. Ah, lots of connectors. I love connectors. And okay. New weapon. Oh, that's in there. Oh, they did not want that coming out, did they? Well, now you gotta go rummaging through a whole box of bits. That'll be fun. Anyway, I'm gonna pull the wiring out through the Yoke bearings, and we'll get to taking apart the Yoke. Finally got the wiring all out and through the bearing assembly. So before I get started in on the Yoke, I'm gonna remove the actual bearings for the tilt. 4 screws for each one of those. Looks like that. All one piece. Okay. Probably the same for this side. Oh no, that side will come out. That mounted on still. Oh yes. Let's see size of the bearing for the tilt for supporting the head. A rather large bearing. Okay, a little C-clip holding that together. Another C-clip here. So I'm gonna pull that bearing out real quick. Oh, that's in there. That's really in there. They're going. There we go. And then pull out the other C-clip, free up the bearing. gonna need to be pressed out, it looks like. That's not moving out easily at all. Got that bearing pulled out, and it's a pretty hefty bearing. 42 millimeters on the OD and 20 millimeters for the ID. It's about 12 millimeters thick. I'm betting there'll be a couple of bigger bearings too in the base. But for the time being, I gotta wash my hands off now. They're quite dirty, and some people have sensitive stomachs. I'll try to help that as much as I can, given the amount of oil and dirt this thing has. Then we'll get back to the yoke. Things should go a little quicker now. Let's start with the yoke, which is this piece right here that does the panning, and it supports the head assembly. Let's take it apart. Looks like there's an inner aluminum piece. We'll get that out and take a look at the board on the inside. Yep, that one's good and in there. Undo these on this side. Oh yeah. Maybe I lied when I said this is going to go a little quicker. Ooh, those are in but good. Holy high beams. Oh, there's glue on those, I see. Yep. That explains a lot. Okay. Ooh. Yep. Little grounding loop right there. Can clip that. Looks like this board is still on a separate piece. I'm going to remove all these wires here. That's an interesting mismatch. Take these out too for the LED. There you go. Various sensors and stuff like that. Oh, wires that go to the fans and the Hall effect sensors and the steppers. So these are for the various steppers. Nice job with the color coordination on all of them. That's some quality stuff. They really did overall make this thing quite serviceable. Speaking of, I know that there's people who might be crying that I'm tearing apart such a lovely piece of hardware. I have two more of these, and if you think this is something that I should do a kind of refurb video on, I'll do a refurb video on the other two moving heads. Looking to ordering up some 100-watt LEDs to throw in the other two movers, maybe upgrade them to a higher wattage LED, get these to be really bright, depending on what I can find that'll fit inside of these moving head assemblies. get bigger fans on the heat sinks too. Keep everything cool. Some little ribbon cable in the back, and it looks like right here is the main logic board. So that's probably going to be the custom firmware on that IC. Probably some op amps on the outside. Now we have this part right here, which is probably one of the stepper drivers. Let's see what it says. Doesn't say on there. Could be a stepper driver. Looks to be a little amplifier IC of some sort. Can't read it with the heatsink on there. I'll throw up pictures of these. That way you can check them out at the end of the video. The ones with the heat sinks on them are usually Darlington arrays, and they're what drives the stepper motors themselves. We'll see more of those ICs with the heat sinks on them as we get into the center of the yoke. Looks like there's 2 nuts on here that I have to undo. Pull this plate off. Brass. Interesting. Don't see brass nuts. Oh, they're tapered. Interesting. Birdie, interesting. I can always use brass nuts for things. Solder sticks to them pretty well. Oh, this is weighty. Wow. There's actually metal weights inside of this. Is that one piece? Nope, that's 2 pieces. So we got this metal bracket here, and this set of steel plates. I'm assuming they're steel. Oh yeah, they're steel. Steel plates, I'm not sure why. Could be for inertia, balancing. That's weird. On to the other side. Actually take this off first. Oh, more insanely tight screws. Yeah, these are all glued. Wow. We weren't messing around putting this together. This was a quality fixture. Oh. Another hard one. Time for a little rap tap tappy tap action. Ooh. Still not playing nice. Time for some bigger rappy tap tap action. Oh man, oh man. Oh, that one's not coming out. Well, that's no good. Try a slightly bigger bit. Nope. Denied. We'll get that out somehow. Let's see if I need to get that out. Nope, no screws. Hopefully that won't hinder us. I'm getting into the rest of it and see how well the other side of the yoke comes apart. Got wires catching up now. Come here. Oh, the struggles. There we go. On this side, it's just a small board, some more connections. Also color coded. That's nice. And here on the bottom, right here is the optical encoder for the tilt. Another wiring harness. We get this side apart. Yeah, these are all glued. That's weird. That glue does not look factory though, I'll tell ya. That looks like somebody else did it. Oh man. Okay, well, this isn't going well. So there's another ribbon cable going through onto this board in the center of the yoke, and that's for different things like they're listed: focus, iris, Gobo, Gobo 2, Gobo 1, GOHS. No idea what GOHS means. I'll remove this Hall effect sensor for the tilt home position detection on the top. So that's it right there. I think we can pull. Nope. Alright, well, what's next? Is the stepper attached to this? Nope, it is not. Okay, so there's the belt that drives the tilt. So it links from the stepper motor down here, the bottom of the yoke, and drives this right here, which does the tilt movement. Let's undo these side screws. Get that stepper motor pulled out. That'll be one of the bigger ones inside of the moving head unit. Now I can pull that out. I see, okay. That all needs to be pulled apart, but here's that assembly. The other tilt bearing. And then where that belt goes on. See about getting the stepper motor off. First, I'm going to remove the optical encoder wheel right here. The optical encoder itself is on this little daughter board. There's two sets of optical encoders, and this is the LED side, it looks like, and this is the photodiode side. And what it does is just like a mouse scroll wheel, it measures when light can pass through and when light can't. And it uses that to determine the steps as the encoder wheel goes through it. Well, everything at this point is a little tougher, isn't it? Alright, well, let's see if we can get the stepper pulled out. Right, those screws are nice and easy. Of course. The piece that actually needs to be tight isn't. That's nice. So here's the stepper wheel or stepper motor with the encoder wheel on it. And this is where the belt goes on. And this handles the tilt motion. That's a pretty big stepper. It looks to be, what, a 55, maybe 60 by 40. Pretty decent. Oh, it has nice little steps too. And that's a decent stepper. Pull the encoder wheel off. I don't need to pull that all the way out. A nice 6mm shaft. And dirt with dead stuff in it. Not so nice. Yeah, that's stuck on there, all right. Put that off to the side. Another little bracket here for holding the tilt stepper motor in place. Two little nuts on it. You can see on the stepper motor assembly itself that it actually has oval holes, so that way you can adjust the tension on the belt if it becomes loose. You can pull this side off. Yeah, that doesn't look like regular, like Loctite. It definitely looks more like super glue. And that's one of the metal pieces for the main support or the Yoke assembly. I'll try one more time to get this one off. use the muscles. By muscles, I mean hammer. Never give up. Never surrender. And here's the other side. Alright, now in the center we have this board right here. And it looks like it has a bunch of those Darlington arrays, which power the stepper motors on the inside. More wires. It's quite the full desk of parts at this point. Well, it looks like the board might have a couple of op-amp ICs as well. Maybe. Not sure. Those are pretty busy ICs. 32 pin and... oh, what is that? 1, 2, 3, 4. 32 pin and 16 pin. Little ones and some 16 pins and a larger 32 pin Darlington arrays under the heatsink. A little crystal oscillator right here. Interesting. I wonder what that's for. Who knows? The capacitors on this board look like they're in pretty good condition. Usually that's what ends up going on these things is capacitors. Either the capacitors, LEDs, or steppers. Get out of there. Is that it? 4 screws? Yeah, just 4 screws. Oops. That popped out. Oh, you gotta be kidding me. Go figure. These screws here on the side. Are squeezing in on the board, not allowing me to pick it up. I'm getting into this teardown. Kind of what happens. Alright. All those labels just fell off. So here's that daughter board. I'm gonna pop in this stepper driver again. Who likes bent pins? There. So yeah, a lot of these are, as I said, for driving the stepper motors. They're Darlington arrays. You obviously know what capacitors are. Little 32 and 16 pin ICs. Little crystal oscillator there. Not sure what that chip is. Little Texas Instruments chip. LR. Oh, these little inductor arrays. Wow. Well, that makes sense to protect the chips. Yeah, they are. I've never seen inline inductors. Huh. That's new. Now I'm really curious. I really want to see what those are. I'll upload a picture of this also up at the end of the video. You can look up part numbers on your own time if you're curious. Alright, get these wires out. More little bolts. Yeah. Looks like those are going to be easier if I take off these metal brackets first. I'll do that. There's not all too much exciting going on in the yoke. It's basically just where the wiring for everything passes through. Well, as I said, it looks like the one main IC for driving everything, the one that has the programming on it, was on the one side. Could be for easy access. Hey, these screws aren't screwed in or glued in. That makes things so much easier. Rusty. I might get tetanus, but at least I had an easy time getting it. Over in this lower assembly here, and underneath here is where it's gonna connect up to the other drive with the belt and everything else that does all the panning motion. So in the base there's going to be another stepper motor with an optical encoder. I get to fish all these wires through there. So at this point, I think it's safe to say this is never going back together again. Of the grounding right there. And more of those goofy bolts to undo. Hopefully these are easier than the ones that were for the tilt. Oh, they are. That's nice. Oh, those are some long ones, aren't they? Oh, they have a bolt at the end. Or a nut. That's, well, you know, I'm not complaining. More hardware for me. Well, this has been a workout, though, let me tell you. This week on Man vs. Machine. Ooh. Right, this could take a while. Now we're officially in the base, and I'm going to go ahead and detension that pulley. Try to work it off so we can remove that bolt in the center and accomplish something. Oh, there's the spring for that. And I think those screws need to be undone as well. Get out of there. So this is the side that does the tensioning, so you can adjust how much pressure this pulley puts on the belt here, and that'll adjust the amount of tension that is riding in this system right here for the pan. I'm going to pull the belt off. Can we? Maybe. Yes, we can. I'll pull that off. And now we can go at that big bolt in the center. Oh, never mind. That is finger tight. Of course, it was the biggest bolt in the entire machine, and it's the loosest. And there's another large bearing. Looks to be the same size as the one in the tilt. So much for having clean hands. Ooh, that's a dirty. Yeah, there are two bearings inside of here, stacked right up against one another. That's suggestive. Two bearings with a spacer. And that comes off. And that's a very similar piece to the other one. Yeah, they look identical. Nope. I'm not even going to bother with trying to press the bearings out of that right now. Well, then I may, when I get all the parts all ordered and organized so you can see them all laid out on the table. So we got this floating piece right here. Now, the moving head does more than one full rotation, and so this piece will get carried along, and it'll stop, and then the other piece will get stopped again, but it just allows for more than a 360 degree rotation. I think it's like 720 degrees or something like that. So this is an important piece. For the love of God, this is so greasy. Dirty. There's another Hall effect sensor right here, which does detection. I think this piece has a little magnet in it. Yeah, it does. So right under here, there's a little magnet that the Hall effect sensor over on this side lines up. Looks like there's actually two Hall effect sensors. So one of them is for this piece, which is right here. And there's another one here for the actual piece that goes on the mover. Where's that magnet? I don't see it. Huh. It's somewhere. Now, I'll try to get this whole assembly apart. And let's see if we can get that stepper all freed up. Hopefully I don't have to undo these 8 screws on the base. I don't want to. I have the feeling I'm going to have to. Is that my hair? Could be. Long enough. Come on out. Undo that one. Oh yeah. Those 8 are definitely part of that frame on the bottom. It's become significantly more messy than I thought it was going to be. Oh. A lot more messy. Bollocks. Oh, those aren't coming out. No, sir. I'm going to move the pair of Hall effect sensors on this little board right here. Goodbye. Right there. The Hall effect sensor for that central little piece, and then the one that goes on the actual yoke assembly. What else can I remove? Move the other side of the pulley tension. Remove the pan encoder wheel. Wow, okay, these set screws are in tight. Oh, really tight. If that one's any looser. Hey. Victory is success, and success is life. if we can get that out with the optical encoder there. Nope. Although I think we can slide the stepper assembly forward. Undo those screws. I want to get as much of the mechanical system out of the base before I even go after the electronics. So that way, here we go. That way I don't have to get grease on these. Figure while I'm here and all lubed up, get the hard stuff done. There's the pair of optical encoders for the pan. Now I can pull up the encoder wheel. Same thing. So just travel through the IR and photodiode assembly, and it just counts steps off. Pretty easy to understand. Alright, next move looks to be that screw here in the corner, and hopefully this stepper assembly will lift up and out then. Hopefully. Yep. Oh yeah, there's those 8 screws right here. Oh, snaking the wire through is always the most difficult part. Except for when the glues or the screws are glued. It's also equally as difficult. Right, well, I'm going to snake all those wires through as best as I can, and we'll get back to the base, wash up the hands, and go over the electronics in the base. Now we're just down to a few more things to take out of the moving headlight base. We got a step-down transformer here that takes 120 volts AC from the mains and steps that down to 11 and 22 volts. Little fan here. This section right here that deals with the user interface and maybe some of the programming. We have the TMX connectors, and over here is the LED power supply. I'm going to take the LED power supply out first. We'll work our way out over to the user interface side. This little board, let's see, 100 constant. Oh, this might be constant current regulator for the LED. So far all I see is a few resistors and a photocoupler and capacitor, but there might be something more interesting on the bottom. Could be shunt resistors. Let's see. Oh yeah, there's a little what looks to be a current sense board of some sort. So I go and clip those wires. So looks like these come from the power supply. And these go up to the LED in the head. Yeah, a little op amp for the circuit. Not much to that board. Let's take a look at it at the end of the video. Off to the side. Take out the LED driver itself. Like nice LED driver. No problems with the capacitors in that one. It's a quality piece of hardware. That's pretty nice. Is it 36 volts, 4 amps? That's a decent power supply. There's a little switch mode power supply. Doesn't look like it has any kind of current sense on it. I don't see any shunt resistor on the power supply itself. Does look like it has an adjustable set point for the voltage. Synpro. That doesn't sound heathenistic at all. That's a quality power supply. We have a little ferrite block in here for suppressing noise. Looks like it's for suppressing the power supply noise going out to the LED. Let's free up those wires. Take out the DMX in and out. Okay. Let's use in the base. There's a screw under there. Nope, there's no screw. So these are pressed into the metal base and won't come out. You have the fuse here. Take that out. All that is kind of glued in as well. Next object, the switch. I'm gonna take the fuse out later. I might take the switch out later. Well, those are in. Right, well. That's a pretty nice switch. That's the 15 amps, 125 volts. 15 amps isn't bad at all. Alright, that transformer is bolted in from the other side. No, there's nuts holding it down. Alright, well, take out the fan over here. It's a nice fan. Looks like a Delta. It is a Delta. Nice fan grill too. Well, after that's washed off, that'll be nice. Probably it works just fine. Oh, I hate when they do this. Oh, it's stupid. Why? Another nice Delta brushless fan. And yeah, looks like another pretty busy board. No screws on this side that I can feel. So, how is that held in? Okay, 4 screws. I see it. Do some of that wiring. Well, it looks like that's for the DMX right here. These look like the main interface for the other IC on that one other board. So these wires would carry the data going between the IC on the one side of the yoke and this board, which handles some of the programming and the interface with the people on the outside. I see 5 volts. These look like they're for different voltage rails. Maybe some low-end signaling. Also relatively well done with the color coordination. Got a lot of the same chips on it. Yeah, tilt, pan. Okay, so this looks like it also does the movement of the tilt and the pan. So these would be more Darlington arrays for those stepper drivers. Got a relay here for protection. A little fuse right there. It looks to be 2 high current full bridge rectifiers as well. And we got the front interface here. So probably the programming on that chip for handling the display and some of the software for the pan and tilt. And could be some RAM. It looks like it could be RAM. It's either RAM or things like op amps or whatnot. I'll also post pictures of this, see what those chips are. But yeah, a lot of the same chips. We have those same 32 pin and 64 pin. No, 32 pin and 16 pin chips. And the same little inductors to protect the chips from any feedback that would come off the Darlington array. Overall in pretty good condition given its age. And I get all this wiring out of the way. And it looks like pretty much the last thing is to take out that transformer. Oh, that goes directly to the transformer. Okay. And last but not least, the transformer. Yo, that's rusty. I'd say that's about it for the actual teardown. I'm going to take out these frame pieces, and then I'm going to just organize all the parts on the desk and see exactly what all was in here. That way we can take a good look at everything and take some pictures, post them up, see if I can find some information on some of those chips, and I'll probably take that time to put them in the video so that way you can read what they are in caption. Here's all the parts that were pulled from the moving headlight, and there's quite a few of them. Let's see what we have. Over here is all the stuff for the mechanical motion of the moving head. So we've got the 2 drive wheels that the belts went on for the pen and tilt, a couple of acetyl spacers, the bearings, and the various bearing hub hardware. Got some of the gears and other parts that went onto the shafts of the stepper motors. And we got the stepper motors themselves. These 7 right here that are smaller were for the parts that were in the actual head, like the color wheel and Gobo wheel. And then we got these 2 larger steppers here, one for the pan and one for the tilt. Over here we got some other hardware, the encoder wheels, handles, the belts themselves, transformer, some fans, some miscellaneous hardware, some pretty decent wire to work with. These are all the large frame pieces. We got some aluminum pieces, some steel pieces, some of the larger structural pieces from the inside of the moving head. Got some of the optical bits here. So we have the lamp reflector, the lens from the lamp assembly, the 3-faceted prism, focus lens, and the output lens, the Gobo wheel and the color wheel, and a very fried LED. And over here we have some of the electronical bits. So we have a driver board for the various steppers inside of the head, the one board that has some of the software for driving those steppers in the head, and the user interface control board along with the board that controls the pan and tilt. I'll get into those in a little bit more detail in a little bit. Various smaller boards here, so sensor boards, breakout boards, the relay, and the small board that attaches to the power supply here for detecting current. A very clever setup they had in that. Anyway, I'm going to go over some of the various electronic parts and a couple of other things. Let's talk about some of the parts that are inside of the moving headlight, starting with the simple sensors. We have 2 types here, Hall effect sensors, which are activated by an external magnetic field, such as a permanent magnet or an electromagnet that's been turned on. And up here, the optical encoders. Now there are 2 optical encoders here, and these are also useful if you take them apart as basic light sensors. Each one of them has an IR LED and a photodiode in them. These are pretty fun to play around with and can be used in a variety of projects, whether they're digital or analog. Well, let's take a look at the LED power supply and the board that went with that. Now, as I mentioned before, this particular power supply does not have feedback for current sensing. And I pointed out that there is an adjustable potentiometer for setting the set point of voltage coming out of the power supply. But they have a very clever solution to make this power supply a current regulated one. This board gets connected to the power supply and has a couple of resistors that act like current shunts. And on the bottom here we have an operational amplifier, and one of these components will be a precision current shunt. So much like a laser driver, what it does is it uses a set point of current, and it uses the operational amplifier to compare the input and output against the precision shunt, and therefore regulates the current. We have the output of that circuit right here, which gets connected to the bottom of the power supply, and that taps into that same circuit of which the variable potentiometer for the output of the power supply goes to. So this board senses the current and then uses the output to tap into the set point, and will adjust the output of the power supply based on the amount of current that's going through that other board. It's a very clever solution, and this kind of setup will work on nearly any power supply. Now I'm going to go into the more complicated bits, and I am by no means a digital bits expert, so bear with me on that one. You've got the user interface and a microcontroller unit, which has all the programming to deal with this. Got these chips right here, which are the line drivers that control the LED segments right here, along with a couple of chips, of which I will link the datasheets on the bottom, and also post up in captions in the pictures following this portion of the video. I tried to look up some of the datasheets for the other components, mainly these 28-pin ones right here, and I could not find the exact information on those. However, it looks like that they're 4 MHz 16-bit microcontroller units. So each stepper has its own microcontroller that goes to it. Now that's interesting. I haven't seen this before, but that explains why we have all these inductor arrays for protecting these chips, as the microcontroller units are fairly delicate. We have 2 inputs here, one for the 11 volts and one for the 22 volts, hence the high current full bridge rectifiers. And over here we have a demultiplexer, which just handles some of the signal processing going to each one of those microcontrollers. We have a couple of latch chips right here, and that just helps with controlling the microcontroller and all the signals going to the Darlington arrays that handle the actual movement of the stepper motors themselves. Let's take a look at these 2 boards, which can be treated as one single assembly, given that they're tied together with this ribbon cable, and look to share one single crystal oscillator to maintain the timing between the 2 of them. But how these boards work is they'll receive a set of serial commands from the user interface board, like the pan and tilt stepper motor driver microcontrollers did, and each stepper motor has its own microcontroller assigned to it. So this is a microcontroller here for the shutter, and it's a larger one on the revision A board. And the revision B board has these smaller microcontrollers here. As I said, each stepper has its own microcontroller and its own individual programming, which determines the function of each stepper, as well as the way it treats the information coming from various sensors. Now these look to be the same 16-bit 4 MHz microcontrollers that were on the pan and tilt driver board. I tried to look up the part number for this smaller IC here. I could not find it, but I'm betting it's a latch IC similar to the ones on the pan and tilt board. I wish I could explain this a little bit more, but as I said, I am no expert with the digital bits, and that's about the best explanation that I can give on this. Now let's talk about stepper motors and how they work a little bit. On the inside of a stepper motor, there's a couple of coils. So here we have 8 coils, and those are in some steel laminate plates. If I push out the rotor, nice bearing, we can see that on the inside there are these little indentations or grooves, and when they're polarized by the coils, they can either have a total north or south polarity to them. When we take a look at the rotor, notice that we have those steel laminate plates on 2 sides, and between them there is a permanent magnet, so one side is north and one side is south. And you'll notice that the grooves are also staggered. So when these coils receive a magnetic flux, it'll move the rotor just a little bit, and depending on the timing of the flux going through the magnetic coils here, it'll step quicker or slower. Then the amount of current going through, voltage and current, the amount of power going into these coils is what determines the amount of strength that each one of those steps had. So speed is determined by the pulse speed, and the torque is determined by the amount of voltage and current. So when a moving head is still, there's still power going into the stepper motor, but that power ends up locking the stepper motor in one position until it receives a new signal to step it into the correct amount of steps that it needs to be in order to move it as much as it needs to move. Bearings are another good thing to have in miscellaneous projects. These 2 from the pan, 2 from the tilt, one of these from the moving Gobo wheel, and the other one from the 3-faceted prism, and these 2 are from the little pulling tensioners on the pan assembly. Here's some of the optics. We got a couple of convex lenses, which can be handy if you're making your own project that has to do with light. And then this lens right here, which is a oddball lens to find, and is good for making your own high-powered flashlights, stuff like that. And the tri-facet prism. This is an interesting part in of itself, although its practical application is a little hard to find. But it makes a really cool visual effect though. We have here the color wheel, and I've already went into some of the practical applications when it comes to lasers. But you can also make your own very colorful lights with these as well. A lot of fun to play with, and it probably looks pretty cool hanging up on a wall somewhere or in a window if you don't have another practical application. And we can't forget the handles, because sometimes you just need a good handle on things. Well, I've run out of screws to undo and parts to remove, so that brings us to the end of this video. However, I do have 2 more of these moving head lights, and if you want to see them refurbished and possibly have larger LEDs installed inside of them so they're brighter, do let me know. I'll keep these other 2 units in one piece for the next few months while I gather your feedback. I hope you enjoyed this video, and as always, stay tuned for more.